If you're in my pre-calculus class, I'm okay with you going to desmos.com just to get an idea because we're just beginning logarithms. But we should be able to graph these without using a graphing calculator too. And so probably the best way is to try plugging in some data points. And the first point I'm going to plug in for x, the first coordinate I'm going to plug in for x is 0. Because a log of 1 doesn't matter what the base is. It's always going to be 0. And here's why. Look, the base is 10, right? So the question is, what power do I raise 10 to be to make it equal 1? 10 to the 0 makes 1, right? So if it was like over here, we're going to do a natural log function. If I have natural log of 1, that is also 0. Because what power do I raise e to be to make it equal 1? E to the 0 power is 1. Anything to the 0 power is 1. So a quick data point you can always grab is by making sure you plug in, making sure you get 1 for the argument. And I got that by plugging in 0 in for x into this one. If I plug in 0 in for x, I get out 0 for y. So that's going to be a dot on my graph. Let's try something else. This is log base 10, so I'm going to plug in 9 for x because 9 plus 1 makes 10. So log base 10 of 9 plus 1, log base 10 of 10, that's 1. So 9 on the x gives us 1 on the y. And then the next clean point for base 10 is kind of far away. You'd have to plug in, you'd have to plug in something really big. But here, these two data points, and I'll show you what the graph of logarithm should look like. Here's -1. Here's 0, 0. That was our first dot. And then we said 9 on the x, 1 on the y was our next dot. So one other thing for graphs of logarithms is that whatever it would take to make the argument be 0, that's going to be a vertical asymptote. Excuse me. So if I was to plug in -1 in here, -1 plus 1 makes 0, and try hitting log of 0 in your calculator. It's going to say undefined. That's because we can't raise 10 to any sort of power to make it equal 0. You can get infinitely close by plugging in -1 billion, but you never reach there. So there's vertical asymptotes where the argument of the logarithm equals 0. So I should have this graph like this. But again, go ahead and check in Desmos. You should at least try one of these by hand, get a couple data points by hand. But if it's a natural log, it's a little harder because e isn't an integer. Okay, let's do what we did before. Remember I said try to make the argument of the logarithm equal 1. So if I plug in 3 in for x, 4 minus 3 makes 1. Natural log of 1 is 0, and -0 is 0. Okay. And then trying to get another integer, you're only going to get, it's not going to work out too well for this one. So let me just get in a decimal value. I'll try plugging in x equals 5, and I'll show you what happens there. 4 minus 5 makes -1. Natural log -1 in your calculator does not exist. What power do you raise e to be to make it change from positive e to -1? You can't do that. An exponent doesn't change the sign of a number. Okay. So you can't plug in -5. That's not going to help us. We can only have positive numbers in the argument of a logarithm. Let's try going the other way. Let's plug in 2. 4 minus 2 makes 2, and then natural log of 2 is 0.693, and then I have a negative sign to apply. So that's a -0.693. Then remember where the vertical asymptotes occur. Vertical asymptotes occur when this equals 0. So at x equals 4, vertical asymptote. Remember x equals 5 didn't work? So our graph should not go over on this side. So if we plug in 3, we get out 0. I plugged in 2 for you. That's 3 should be over here. I plugged in 2, and I got a negative number. And so what we're seeing is if you plug in numbers closer and closer to 4, this is going to be a negative value for logarithm. So watch, if you do 4 minus 3.99999 and take a natural log, it's a negative number. The closer you get to 4, the higher this thing rises. So you should be seeing a graph that looks something like this. The vertical asymptote is pointing up this time. Okay, but go ahead and graph those in Desmos to get an idea for what the graph of logarithms look like.